So I've been setting up this project with a very basic character. I currently have no visual style for the characters, and I have no way to test the performance of the characters, so we'll now be creating various characters for testing. I do also want to start working on pipelining of characters, and this will potentially include things like character creators. Even if I'm not using a character creator and making every character manually, there will still be parts of the body which are very consistent and can be reproduced consistently. And the first and most obvious of these will be the eyes. So now I'll be creating a basic eye setup. This is going to be an eye setup for game characters and not an eye setup for film characters, although we could always extend this. With film or cinematic characters, there is no limit on detail, and the eyes are one of the most difficult parts of a character to get right. So for cinematics, the eyes will be disproportionately detailed compared to the rest of the body. So this will be reasonably basic, and there is a lot that we can add for the eyes. So here we'll have a basic eye, and the most notable parts of the eye will be the sclera, or the white of the eye, and the iris, which is the colored part of the eye which we will perceive. The main things that we need to know for these are the diameter, and these will almost always have a consistent proportion, where the diameter of the iris is half the diameter of the eye. So we'll have the diameter of the eyeball. This will have an approximate distance of 24 millimeters. The diameter of the iris will be approximately 12 millimeters, which should be half the diameter of the eye. There will be some slight variation in these distances, as the diameter of the height of the eye is not actually the same as the diameter of the width of the eye. The width is usually slightly wider than the height of the eye. The diameter for the width will usually be about 24 millimeters, where the diameter for the height is actually about 23 millimeters. The difference in this distance is not particularly large, and is usually not more than a millimeter. So we can ignore this and say that our average radius will be 24 millimeters. We'll also need to consider what the eye looks like from the side. The majority of the eye will be represented as a sphere. However, at the front of the eye we will have the corneal bulge. The cornea is not the lens or the pupil, but it does have a huge influence on how we focus with the eyes. The cornea will be the same size as the visible section of the iris. The cornea is transparent. The cornea is very important, as a lot of the eye's reflections depend on the shape of the cornea. Reflections off the cornea will have a huge influence on how believable our eyes are. I will not be working off physical measurements for the cornea. The cornea can actually be exaggerated a little bit. It's often better to emphasize the cornea, as the cornea will have huge influence on things like the eyelids as well. For a more detailed eye, we will also want to simulate a transparent film on top of the surface of the eye, as there are multiple layers to the eyes. Generally, the eyes are more opaque than the skin, but they are also more reflective, and unlike the surface of the skin, they are also generally wet. We'll often add a second layer to help simulate these properties, but it's not something which I'll be doing in this eye at this point, as those extra layers are really needed for film, and this will give us a large extra amount of polygons when we do not yet know how close we're going to have the camera to the character. Behind the cornea there'll be an empty space, and then we'll have the iris, and at the point where the iris and the cornea meet, we will have the limbal ring. This is often perceived as a dark circle around the outside of the iris, and it's often more prominent with people who have light eyes, especially blue, grey or green eyes, but it does also occur in people who have brown eyes. It's usually more prominent on people who are young, so if we want to represent somebody who is very elderly, we'll make the limbal ring less prominent or remove it completely. The limbal ring is actually not part of the iris, but is part of the cornea, and therefore it has a volumetric aspect to it. So for a cinematic ring, we would actually want to convert this into a volume, as that would give us the best result. I will initially leave this out, as it can be simulated as part of the iris, even though it is not literally part of the iris. The representation of the limbal ring will depend heavily on the type of character that we're creating. The next thing will be the construction of the eyes within the head. Here the most important thing that we'll refer to is the pupillary distance. This is the distance between each of the eyes, and it is the theoretical distance which you get when the pupils are facing forwards. There is a large variation in pupillary distance. The average male pupillary distance is about 64 millimeters. For women, the average is about 61 millimeters. There is a lot more variation for the pupillary distance than there is for the eyes themselves. The minimum distance for women is usually about 51 millimeters, and the minimum distance for men is about 55 millimeters. The maximum distance for women is about 74 millimeters, and the maximum for men is about 77 millimeters. So these are the basic things which you'll want to take into account when we create an eye system. I'm going to set up the eye system so that it can be attached to any rig. I will also eventually set it up so that we can create the eyes separately and have it modify the rig so that the rig conforms to existing eyes for character, as this will make it easier to both rig and model characters in the future. This will also be required if I decide to build a character creator, so it will be easier to set this up now and not worry about integrating it later if that is necessary. So now I'm going to be working on an eye setup, and this is a guide for an Apex rig, which is being set up with my proxy character. I will probably want to slot this node in after I've set up the weights for the character, as this will allow me to enforce weights for the eyes explicitly. So ideally I want to slot this in either after I create my controls or after I set up the weights. Initially I'll set this up after my controls. I'll do this by creating a subnetwork, and I'll connect this to the output of the node where I'm generating the controls for the rig. This node has 3 outputs, the first of which will give me the mesh of the character, the second of which will give me the skeleton which will deform the character, and the third of these is to store controls for the character. The geometry from these outputs will be converted into the rig later, but the most important things here are I'm updating the skeleton for the character, and I'm going to update the mesh for the character. The controls will essentially be passed through this rig, although in the future I could update the positions for the controls based off the eyes within this node as well. I can enter the subnetwork to work on it, and I'm going to color the inputs. For my coloring conventions, my mesh is green, my skeleton is purple, and my controls are orange. I want outputs for all of these, so I can duplicate my output node. I'll need to update the output index for each of these. My controls will be output index 2, and my skeleton will be output index 1. So essentially this will pass all my existing data through this node. I can now add eyes to my character based off the skeleton. So we will want to add eyes to the skeleton coming into this node. However, we want to be able to create eyes for any character, and we want to be able to create eyes for when we do not yet have a character that exists. So I'm going to be creating a skeleton for my eyes. I'll be creating this manually as it gives me more control. I'll do this with an add node. I will want 3 points. I'll separate these points in the viewport to make them easier to manipulate. And I'll place the first point at 0 in the world. I'll then raise the other 2 points in Y. Initially I'll give these a value of 0.02. I'll need to reposition these along the Z axis as well. I'll give these a Z position of 0.015. I'll use a pupillary distance of about 0.61. These will be centered around the world axis at 0, so I'll need to give these an X distance of half of that. So for the right eye, this will be negative 0.0305. For the left eye, this will be 0.0305. This will give me some initial eye positions to work with. I'll want to convert these points into skeletal joints. In order to do this, I'll need to give them names, and I'll do this with a name node. This will have 3 namings. The first joint will be my head. I'll then have my left eye. And finally, we'll have our right eye. The name will need to be a point attribute. I'll need to add transforms to these. I'll begin by adding transforms as world space transforms, and I'll do this with an attribute wrangle node. The transform attribute will be specified with 3@transform, and I'll set this with an identity matrix using the ident function. This will allow me to parent these joints. This will be done with the parent joints node, and my eyes are going to be the child of my head. For the child, I'll use a wildcard, so this will be @name is equal to *I. This means that both eyes will be a child of the head. I'll shift these eyes forward a little bit. So this will give me a basic skeleton, and we can attach our eyes to the skeleton. I can now use a rig pose, and I can reposition these joints, so I can align them where I need them in my character. I'll finish off this network with a null for the moment. I'm then going to get an item to test with. This is not going to be our eye. It's not going to be part of creating our eye, but I do want to be able to match up my eye, and I'll do this with a temporary object first. So for the moment, I'm going to work with the sphere. I want the sphere to face down the Z-axis, as that is the position which I want to create the eye geometry in. I can then specify the size of the sphere. I will want to specify this with millimeters. This will be working with the radius, so this will be half the length of the diameter. The diameter is going to be 24 millimeters, so the diameter here will be 12. And for this to be millimeters, I'll set the default radius to be 0.001. And this will apply for the X, the Y, and the Z axis. So this should give me the eye to the correct world scale. This should be a reasonably average human eye setup. I will want to be able to get directionality from this eye, and for this I'm going to add color to the eye. I'll do this with a color node. Here I'll specify primitives at the front of the eye. I'll specify color for these primitives. So this will give me a direction for the eye, and I can now transform this eye based off the skeleton. So I can now transform my eye, and I'll do this with a point VOP. My temporary geometry will be connected to the first input. I'll then connect my rig to the second input. I can enter the VOP. I'm going to use a get point transform node. I'm going to specify my transform by name, and I'll begin by specifying the left eye. This will give me a transform for the eye. I'm going to multiply the point position of my eye geometry by this matrix. I can then test my network. I'll connect the output of this to my null, but this is not working. So I have made a mistake somewhere. I'll check my naming, and my naming is correct. So I'll re-enter the point VOP. I've made a mistake with the get point transform node. This should be getting the point transform from the second input. My eye is now positioned at the skeleton position. I should now be able to manipulate my skeleton, and when I manipulate my skeleton, the eye should be moving correctly. I do, however, have an issue here, and that is this eye will not actually match the transform space of my skeleton. For this setup, I'm using a rig which has a y-axis which faces down the length of the bone. Essentially, I've set up my bones to have the same axis as the world axis, as doing this allows me to simplify a lot of conversions, as each of the bones will have an identity matrix as a default transform. However, that means that I do need to convert this to work with my rig setup, and currently these joints are not compensating for the way I've set up my rig. This is something which will be very dependent on the rig setup you use, as by default most rigs will have bones pointing down either the negative z-axis or the positive z-axis. I could test this by rotating the eyes by 90 degrees, and this would be 90 degrees in the x-axis. This, however, will not be a proper solution, so I will want to adjust my transforms before I pose them. I'll get a rig attribute VOP, and I'll connect this before my rig pose node. Within this, we can add a get point transforms node. We'll need to work on each of these individually, so we'll work on them within a for each loop. The for each loop is going to run over the point numbers. I want to specify that I'm looking for the eyes. The group will be @name is equal to *eye. The eyes will need to match the transform for my skeleton. We're not going to be matching the head, and the head is actually close to my skeleton transform in any case. I'll clear out the transforms from my rig pose node, so I can more easily see the changes to my transforms. We will need to update our transforms, and these will be updated one at a time, so we'll use the set point transform node. I'll need to get my individual transforms, and the transforms are currently part of an array, so I'll need a get array element node. The array will be set by the transforms array from my get point transforms node, and the index will be set by the index out in my for each loop. The element will give me the current point, which is the joint number, and this will be used to set the set point transform node. The transforms will be set by my existing array. This will give us exactly what we already have, and now we can update these transforms. There are a lot of ways I can do this. In this case, I'm going to rotate the transforms. I'll do this with the rotate node. The default axis for rotation is the x-axis, and this is the correct axis. So I'll need to specify the angle. However, this node specifies the angle in radians, and it is usually easier to specify angles within degrees. So I'll get a degree to radians node, and I'll set my axis to be 90 degrees. And I can test this, but this will not work correctly, and that is because we are rotating the entire transform. We're not just rotating the joint in place. So I want to specify that the rotation is only affecting the joint, and the position is not going to be affected. So I'm going to rotate the joint individually, and then I'll update the position. So I'm going to convert this into a rotation matrix, and I'll do that by converting my matrix 3 back to matrix 4. I'm then going to separate the components with the vector 4 to matrix node, and I'll reassemble them with the matrix to vector 4 node. I'll use the matrix to vector 4 node to separate my matrix. I'll then duplicate that, and I'll use this to separate the original matrix, which I'll set from the get element node. I'll then set the rotations from my rotation, and I'll set my position from my original matrix. The result of this can then be used to drive the transforms for the eye. This should update my transforms. This is probably too complicated a way of doing this, as it is far easier to just manipulate transforms, but this is a way of approaching this. I should now have my updated eye transforms, and this should allow me to see the actual rotation for the eyes, which will be the net rotation which I'll get for my final skeleton. This position for the eyes is not particularly good as it is facing downwards, and for this I'll need to update the way I'm transforming my eyes. Once again, I'm going to update the matrix, but in this case I'm going to do a very simple matrix manipulation. For this I'll use a matrix to vector 4 node as well as a vector 4 to matrix node. I'm going to connect these nodes together, but I'm going to swap around some of the axes. My x-axis will not change, but I am going to swap my y and z axes. The w-axis, which is my position, will not change. I can then use this to set my transform, and this is giving me a correct result. However, it is inverting my surface. To reverse these, I'll get a negate node. I'll need to negate the y-axis, and this is the y-axis which is being set from our z-axis. This will give me a correctly positioned eye, and this will allow me to pose the eye with the rig. This, however, only affects one eye, so I'll duplicate my point VOP, and in this case I'm just going to update the name. So I'll update the name within the getPointTransform node to be right eye. If I get to the point where I'm having a Cyclops or characters with a lot of eyes, I may change this, but for the moment this will be hard-coded. These nodes can then be merged together, and we should now have two eyes which can be manipulated with the setup. Next I'll begin on the construction of the eyes, which will give us more accurate eyes to work with.